All right, people, we are looking at quiz number 1. Okay, a vector v is shown in the following figure. The magnitude of the vector is 20 and the angle is 60. The x and y components of the vector are, let's see if I can just move this out of the way. I'd like to get to this. All right. So what we have, x here and y here, and we have a vector like so. We have an angle theta, that's 60. The magnitude is 20. So what that's just saying is the length is 20. So you want to find the x and y components. In order to find the x and y components, you do like so. This would be the y component. And so this is what? The red side. And the green side would be the x component. Let's call this the x component. X comp. Let's call this y comp. What is the y comp? We use so ka toa. So ka toa. We having a so ka toa party. Come on in. All right. So is the opposite side, which is here, over the hypotenuse, which is here. So the hypotenuse, in other words, the hypotenuse would be at the bottom, but we're just going to bring it up here. Y'all follow? Let me show you. Sine of theta equals to the opposite side, which is y comp, divided by the hypotenuse, which is 20. Okay? And so that means y comp is just going to end up being 20 sine theta, which is sine 60. So you guys are going to actually find that, put that in. I sure hope that I started the screen. I didn't start this, did I? I should have. Oh, I did. Thank you. Thank you, Lord. Okay. And our x comp is going to be cosine of theta equals to the adjacent side, which is our x comp, divided by our hypotenuse, which is 20. Cool beans? So our x comp is going to equal to 20 cosine 60 degrees. So you said that this one is 17.33. And this one is what? 10? 10. All right. That's how you solve that. All right. Now it says find the sum of the two vectors shown in the following figure by using the I was about to say the Pythagorean, but that's not right. The parallelogram rule. So how do you do that? All right. I think we had a vector that went in this direction, and we had another vector that went in this direction. So this vector is, which this is A. And what is this vector? B. So if you're going to use a parallelogram method, you want to run something parallel to vector A. All right. And then you're going to run one parallel to B. And the parallelogram method is going to be like so. So what is that? A plus B? Is that right? All right. So even though it looks like this, when you guys go head to tail and all that stuff, they just move this vector back. They'll move this A vector back here, and they'll move this A plus B vector over here, and it'll look like head to tail. And so that would be B, this would be A, this would be A plus B. All right? But this is the parallelogram method. I gave that extra stuff. I ain't need to do that. I'm sorry. Forgive me, please. It is. All right. The last thing. Find the moment of force about point 0 in the following figure by using the vector cross product method. So let's see. We have a force going down. And it's going down. Well, that's 10 newtons, right? How do you do this? So if this is the origin, if OO is the origin, all right, find the moment of force F about point O in the following figure by using the vector cross product method. So if this is OO, we would need to resolve this vector. Let's resolve that into components. And we know what this vector is. We know what the actual, how can I say, the length vector is. The lever arm is 2 meters in the X direction and 2 meters in the Y direction. Y'all see that? So when we use the cross product, we need to find what's in the X and the Y direction for the force. And we have to do the cross product appropriately. Y'all follow that? So let's do that. I'm going to try not to give y'all too much this time. So this is 2 meters, 2 meters. And we have a force acting at 60 degrees, like so. Is that right? Being made with this normal. And this angle, is this the angle that they give us? And this is 60 degrees. This force is equal to what? 10 newtons. So let's find the components to this force. The components to this force, like so. That's one component. Here's the other component. So you have a component in that direction, and you have a component in this direction. So F of X is equal to what? What do you guys think? It's right next to the angle theta. Say that again, Joe. So it's 10 cosine of 60 degrees. If somebody could figure that out. You say 5. Okay. About F of Y. 10 times 60? Correct. What is that equal to? 1866? 8.66 newtons. So now we know what our force looks like. Our force looks like this. 5 newtons in the X direction plus 8.66 newtons in the Y direction. Cool beans? And now our lever arm, which is R, both of these are vectors, by the way. Our lever arm is 2 meters in the X direction plus 2 meters in the Y direction. Can you see that? So now if we're going to do R, if we're going to find the torque, it's going to be R cross F, 2 meters I hat plus 2 meters J hat crossed with, what was it, 5 newtons I hat plus newtons J hat. So we're going to cross 2i cross with 5i is what? Okay. So this is 2 meters cross 5. Why did I do that? This is going to be 10 times I cross I Newton meters. So that's taken care of. And then you have 2 times that, right? So that's 17.32, and that's going to be I cross J, Newton times a meter, correct? And then 2 times this. We're using the FOIL method. So that's going to be what? 10 J cross with I Newton meter, and then we have this times this, 17.32 J cross J Newton meter. Now whenever you go ahead.
Is it I times I if they're the same? It's 1, and then if they're the opposite, it's 0, or it's the other way around?
In this particular case, whenever you do I cross with I, that's the same thing as saying the magnitude of I times the magnitude of I, sine of the angle between them. What's the angle between them? Between I?
Oh, wait, 0.
0. So what's sine of 0?
Sine 0 is 0.
What do you think, Michonne? Say it again. 0 is correct. So whenever you have I cross I, it's 0. J cross with J, 0. K cross with K, 0.
And if it's the opposite, it's cosine.
Well, that would be for the dot product. Right now we're working with the cross product because we are dealing with torque. So we only have 2 pieces that are left. And before we go any further, what is I cross J? This is I. This is J. If I cross I into J, what do I get? K. So this is K. What about J crossed into J? J crossed into I.
That's
Negative K. Very good.
It's in there in pieces, but it's in there.
Right. So we're getting 17.32 Newton meter K hat minus 10 Newton meter K hat. Right? So that means our torque is what?
7.32 Newton meters K.
In the direction of K. Very good. Yes. So that was quiz number 1 from Unit 1.